Okay. Next up, we have Seung-Jin Sul from the Joint Genome Institute. He'll be telling us about JAWS, an acronym without a DF in it, finally. So that is the JGI Analysis Workflow Service.
Thank you. Thank you. Good morning. My name is Seung-Jin Sul, and I'm a software engineer, and I'm from Joint Genome Institute at Lawrence Berkeley Lab. I'm very glad to be here to talk about JAWS. It's a scientific workflow execution service using Condor. So first of all, who we are. So GGI, it is a high throughput AI-centric genomic science user facility located at LBNL. And we provide genomic capabilities mostly. So we have sequencing machines on site. We sequence data and the other things like filtering data, sample data, the sequence data, and curate data. And we also support users with many portals so that they can look up the curated data and sequence data through that website and download those files for their further research. And we have many experts like domain and workflow. So we support globally the researchers to study the complex biological and environmental systems. So this is our achievement in 2024. So we got primary user 2,600 primary users all across the world. And they provide us samples, environment samples and biological samples. We sequence them through these many programs, and we curated that data and upload those files to the portals, and they can use those data to proceed their researches. And 2025, we generated 1.114 the petabases of sequences and synthesized 8.5 megabases of DNA and processed 70,000 metabolomics samples and 20 petabytes data amount of the output data. So the reason I show this table is that the slide is that the GJ is running tens of workflows daily on HPCs to process this huge amount of input and output data. Sorry. So let me just bring you back to 2015 of GGI. So we had many issues over that time. So the programs, many programs, they have the workflows to run, many jobs dedicated to nurse machines at the time. And the problem is that we had before is that they have many the workflows and written in different languages. And the workflow itself, here is a glucose, the workflow itself is implemented all whole different ways per group or teams. And the way to dealing with the HPC itself is different, how to allocate the node, the request nodes, all those methods are all different across all the programs. So that results in low maintainability. And those workflows are specific, customized to the HPC clusters. So if the nurse has a downtime like maintenance, we had to stop the operation. So that is a big impact for such kind of facility to produce the big amount of data. So we also try to use other DOE HPC facilities, but the data movement is a big headache. It's a petabyte data and it's done by each team should manually transfer data. So that's another headache. And it is really hard to run the workflows without any change on the other HPC facilities because it's quite customized to the HPC cluster on nurse side. So if we move that workflow to other facilities, it's really hard to run over there without any change. So for example, different HPC environments like battery system is different, like PBS and Slum, and container system is all different, Podman, Aptain, shifter, and also charging account, security and data privacy, all kind of headache. It's very hard to overcome. So the answer to those kind of challenges is the JAWS. And we developed a workflow management service called GGI Analysis Workflow Service. And we try to unify the workflow across GGI groups and whole DOE facilities. And usually write their workflows in workflow description language, WDL, is a kind of standard thing. And JAWS takes care of everything else. So the moving data in between facilities, the output data moving and handling all the complexities of HPC, the backend, the parameters or disk system, and executing workflow under the hood. So user can write once the workflow in WDL, and they can run the workflows everywhere, every other the DOE facilities. So this is just components. So of course, the user writes WDL, and JAWS handles the rest. So we have roughly 6 major components over here. So the JAWS client is the interface to the user. So we provide the user with CLI and API, which is Python library, and we also provide REST endpoints so that they can call easily from their applications, so that they can do submission, status checking, and cancel the job or see the logs and errors, something like that. And the overall system, we have a single central running on LBL side, and currently we have 11 sites all across the HPC facilities. And for the file transfer in between those components, we are using Globus, and for signaling and command setting, we are using HTTP and AMQP protocols. Chromel is developed by the Broad Institute. It's really powerful, the customizable, the WDL execution engine, and it reads WDL and figure out the dependence between the tasks, and then we configure Chromel to write the Condor submit files, and Chromel submit those files to Condor. And of course, the Condor is the most important part of our system, job scheduling execution. And we are based on gliding. So the pool manager, which actually dynamically scales the local site pool up and down, and by communicating with Slurm and PBS. And we had a support for AWS before, but for some reason we disabled it, and we are working on Kubernetes as well. So this is a very simple example of WDL. WDL looks like this one and consists of 2 sections roughly. The first section is just a workflow section, name and list of tasks to call. And the other sections is the definition of those tasks one by one. So here we have hello workflow, and there's only say hello task in there, but we can call many tasks. And the inside of the parentheses over there, we can specify input and output so that we can define the dependence between the tasks. And the output is a final object of output of this workflow. And task definition, it consists of 4 sections, roughly. So the input, command, output, runtime. The input is, of course, the task input, and command is a list of command, the Python, Bash, whatever, to process that input. And output is the final output from this task. And we have runtime section. This is one of the most important sections for our service because it defines the compute resource requirement for this task. So for example, here, we're gonna use Docker, whatever, and we need 1 CPU and 2 gig memory and 3 mid runtime. So it is read by not only pool manager. Pool manager read this information so that it can provision the node and the Condor pool. Also, Condor scheduler uses information to schedule jobs. Okay, this is overall flow of your system. User writes WDL, and they can use the interface. Here is a CLI, the example. Just submit and main WDL is a WDL name. And input.json is a kind of additional file so that they can define variables like file name or some tool parameters, options, something like that. And final thing is the site. So they can specify, I'm going to run this WDL on such site. And once the central receives that the request, it notifies the site, okay, we're gonna have 1 job. And it tries to use global file transfer to transfer the info files from the user and all the other files like WDL files to destination site. And once those files are staged on specific site, those site process the WDL to transfer to Chromel, to submit to Chromel. Chromel will submit jobs to Condor, use the pools, something like that. So the rightmost part, I will show a little bit detail in next slide. And the other additional services we have is a dashboard service. So We have 11 sites, and per site, we have roughly 5 or 6 services running per site. So we have a way to monitor the healthiness of those sites and services. And we have dashboard too. And job monitor, once you just submit job, they can see progress of job is ready or progressing or done, failed. And they can see each task, the performance metrics as well, such as the CPU or memory usage runtime. So it's the kind of things also shown up in the dashboard so that they can see what's the reason for my failure or my task is going well or not, something like that. So this is the rightmost part, the full manager and control grinder part. So the ChromeL reads the WDL and creates a DAG and creates the control submit file, and using control submit command, submit to the Condor. And Condor, these jobs will be stacked in the Condor queue. At the same time, full manager, this one is actually reads the queue constantly, the Condor queue. And if there is a new job, and if there's no compute pool is available, it requests node through the batch scheduler, considering memory and CPU, GPU, and work time. And if when this node is allocated and ready for run, this is registered as the slot of Condor worker, and then Condor starts scheduling jobs to there. But if there's no job in the Condor queue, the pool manager tries to shrink the pool size to 0 so that we can minimize the number of idle nodes. And even if there is jobs in the queue, we also try to check the allocation so that we can also minimize the number of idle nodes in this system. So it's based on sliding, so we need to save the CPU hours per user. And we have for the worker pools, we have 5 categories of worker pools here based on mostly the memory size. So each site has different set of node types. So for example, Permira is one of the HPC cluster from NERSC. They have GPU node. So we have GPU pool and large compute pool. So in our term, the large pool is roughly 500 gigabytes of the memory space. And for example, Dory, we have small, large, extra large pool. Small is just one CPU, very short job, so that the user can test their jobs, or we can test a very more simple, the operational jobs, something like that. And large is similar with the Permira case. So we have, on Dory, we have 500 gig machines. So we set those machines into large cluster, large pool. And we have also extra large pool, which is high memory node, it's a 1.5 terabytes of memory. So there's usually some sequence analysis needs a very large memory footprint, so users submit those jobs to there. And another very useful feature is min-max pool sizes for pool type and site. So for example, on Dory, this is the site we are using right now. We set large pool size as minimum 10, which means that 10 compute nodes will constantly running regardless of there's job or not. So usually this Dory site is really busy. So using this feature, hopefully user can minimize the QA time and increase the response time. And we have a scheduling policies, of course. So it's the Condor the configuration. So for example, work time limit is that we configure, it's a custom classes so that, for example, 1 hour job shouldn't be scheduled to a node that has less than 1 hour lap time, the work time, right? So this is to kind of increase the utilization and retrial time, the minimize the retrial time. And also we have many general housekeeping policies like memory overscription, and some job stays in idle for a long time, something like that. And also we are working with the Condor team about slot defragmentation as well. So this is an example of dashboard. Here, top part, we can see user can search any conditions like site name or status, done or failed, and they can specify some keywords to look up for title and name and tag, something like that. And each row has run ID, job name, and the user and site name. And if user click one of them, they can see the expanded version which shows all the tasks inside of this workflow. And if user click one of those tasks, they can see the performance metrics like the CPU and memory and disk usage or runtime, all these matters. And this is our score. So the JAWS project started in 2019. I still remember the day me and two others of engineers just drew big two circles in the whiteboard. One is central, one is side. That was our start. And 2022, we can have a kind of organization-wide training. So that's the reason why we have this user spike over there. But after that, we are having the increasing number of runs. 2025, we got 36,000 runs. And 2026, we hope double it up because just JAWS system is adopted by many automation workflows inside of GGI. So yes, and so all based on partnership collaborations. The JAWS project is so. We have JAWS users, of course. We support them, convert their previous pipeline conventional workflows into WDL, and they write their WDLs and give us many feedback like what things to improve or the bottleneck, something like that. So there's a first the contributor to this contributor for this project, and many others over there, including the Condor team. They are really supportive and then allow us to troubleshoot many issues in JAWS project. And middle, we have HPC facilities we are currently working on. And rightmost is the list of sites we are currently running. So user can submit those sites over there as a kind of last parameter of the JAWS command. Okay, that's the future work. So we are expanding sites more. So we are looking for collaboration as well. And for now, service resilience is the first priority because we are getting more sites. So we need to manage those sites services more healthily, so and perfectly, I mean. So we are going to do some monitoring, or we have monitor service right now, alerting service as well, but we are going to enhance those services and telemetrics, Victoria metrics, and low-key for aggregated logs. So this is not just for the monitoring. So what we are going to do is based on those data, we are going to do a kind of AI support JAWS system, JAWS.ai. So which means that for the first target is, you remember the last parameter of the JAWS command, this is site. So we're going to remove out the site. So if you just submit job without the site name, the JAWS.ai will determine based on the requirements and availability of the sites and all the compute resource type, it will determine which site you should send those jobs. And also in future, near future, we hope we can remove the users from writing the WDL. They don't need to write WDL at all. They just say, hey, JAWS, I need to process this data. Just do that. That's it. Okay, I would like to give a big thanks and huge shout out to JAWS, the Condor team over here. Thank you very much. And the NERSC was also very helpful for us to set up the NERSC site for the JAWS services. Okay, that's it. Thank you very much.
Okay, so Stephen first.
So it looks like a very strong program overall. My question is, how many hurdles did you have with getting all those various HPC sites to authenticate your automated system? Because this is something that all people that work at HPC sites have to deal with. And furthermore, at least NERSC has changed their auth a couple of times in the last 5 years or so. How are you dealing with that? Then I'll have a follow-up.
So we have a kind of the encryption layer for that the HPC handling, which means that we have separate layer of simply say we have different set of and the tools to create the simplifies the slum submit files or PBS submit files, that those files are created independently on the Joe system. So if some underneath HPC system change it, we just modify that part so that we can have correct parameters in the submission file, the job request file. That way we can cope with any changes of the underlying HPC system.
And then also as a DOE center, how I noticed on Oak Ridge you're only on Defiant, which is their dev machine. Have you made any progress towards it? You think you'll ever get to an Insight level of DOE involvement, or what level of allocations are you at, and how has that process been over the years?
I think I'm not following your question. Sorry.
No, in other words, how are you getting bigger allocations on the DOE HPC sites to do as your thing grows?
Oh, so yeah, that's another thing we are figuring out. So we are getting more users and getting more submissions. Yeah, you hit the limit currently. So the only way we can do right now is that keep talking to the nurse administration, so that we can have more the CPRs needed to drop something like that.
Are you big enough for an Insight grant at the leadership facilities yet, or not? Insight is the big. Okay.
Yeah.
So one question I had real quick, I noticed that, usage is going up, but users kind of flat. Is it because, you have 40 users and they're so happy and they're sticking around, or is it or trying to find more users and
there are two reasons. First, some of the user account is a kind of collaboration account, so many users use the same account. And second thing is that, yes, you're right. So some specific set of users submit a large number of runs currently, and they adapt more the JAWS to their application as well. So that actually explains that trend.
Yeah. Thank you. Very nice talk. On slide 9, I guess I had a question for you in the group, but on slide 9, you showed Cromwell taking a WDL, workflow description language, and kind of spoon feeding HTCondor. I guess one slide forward, back, some.
This one.
There you go. Now, one thing that we've been talking about with JAWS is maybe a compiler, if you will, where you give it a WDL file, and how far could we get in just kind of statically converting that to either a DAG or a DAX file that could just be given directly to DAGman or maybe with Pegasus to DAGman. Just curious, anybody in the audience also interested in WDL or use WDL? And hands up. But we're thinking a lot of that control flow could be translated directly to a DAG control flow. I mean, a WDL is a DAG by definition.
Yeah, you can start from an existing script, you can start from a napkin, you can start from a paper, and obviously you need to have domain knowledge, but you can use AI to help you translate very high level, human understandable descriptions into a specification. So ask AI to generate a specification of what you want to do, which is, again, human readable and inspectable. You can inspect that, make sure that it understands what you want to do, and then you generate the code, and it can be any code that you want. For us, we obviously generate Pegasus, but it can generate other things as well. And so I think in my mind, I'm sorry to say, but I think the specific language, different language workflow languages would be just an intermediate form. It would not be something that the user, a scientist, will have to deal with.
Okay.
Thank you.